right, so every exponential function can be written as a log. Right, so when we have a log expression, we have log, and then down here a base is written. And then here we have what we call is the argument. But really all the argument is the answer. That's going to equal the exponent. Okay, so let's say I have, I'm going to use all variables here, log base b of a equals e. This is way too, pick up a marker. Oh, sorry, equals not ey. Sorry. If we want to change this into exponential, my base is b. What's the exponent? Y. Equals my argument or the answer, which is a. When no base is written, it is known to be a base of 10. So an example would be if I just have log x, that's the same as log base 10 of x. Okay, when the base is e, it is written as ln. So an example would be ln of x is considered log base e of x. And ln, the name of it is called the natural log. So anytime you see ln, it's called the natural log.
be NL?
NL?
It's natural log.
You would think, right? But no, it's LN.
Who came up with this stuff?
Me. I don't know. Okay, we ready? So now let's do some sample problems. I want us to change from log to exponential. Okay, so in this one, we have our base, we have our argument. What does the argument represent? Our answer. What are we missing? The exponent, right? So if we wanted to, you don't have to, but if you wanted to, if you get confused, you could put log base 2 of 8 equals x. So now we're going to change this into exponential. So it's going to be 2 to the x is equal to 8. Oh, that whole graphing unit we just did, that was all pre-calc.
Wow.
That was good. Okay. That we spent months on. All right, 2 to the x is equal to 8. So now we solve this. In order to solve this, think about last class. What did I ask you to do with the bases? Make them the same, yeah. So I'm going to have 2 to the x is equal to 2 to the third. Therefore, x is equal to 3. Okay, if I have log base 5 of 25, change it back to exponential for me. How can I do it? Nico?
Showing it. Okay.
Anybody? I don't care. So?
5x equals 25.
5x? Good. 5 raised to the x power equals 25. Do we really need to create the same base for this? No, we could do this in our heads, but just for fun, let's create the same base. What is the same base? We're going to make them both into 5. So 25 becomes 5 to the second. Therefore, x is equal to 2.
Is it the same thing, like if it's positive, you have to do positive or negative?
I don't... No, this time we only... You mean plus or minus? Is that what you're talking about? No, that's only when our base is a variable and it's raised to some fractional exponent. So for this, we just solve this. So isn't this 1/4 to the x power equals 16? What's wrong? Okay, so now I don't want to deal with the fractions, so what should I do with the 1/4?
Negative integer.
Good, make this 4 raised to what power?
Negative 1.
-1. And what am I going to do with the 16, do you think?
Same base.
Change it into what? 4 to the
No.
second. Yeah,
Yeah.
4 to the second. So now I have 4 raised to the negative x power is equal to 4 to the second. We go ahead and we solve this. Negative x is equal to 2, so x is equal to -2. next one, 4.
Any problems over there?
We have 2 more in this section, then I'm going to teach you some new rules.
There's more rules?
There's more rules.
Yeah.
These aren't bad, guys. So here what I want to do is I want to change that radical into an exponent. So this is going to be log base 2 of 32 raised to what power?
1/3.
1/3 equals x. So here we're going to have 2 to what power? 2 to the x is equal to 32 raised to the 1/3. What should I do now?
Equal bases.
Same bases. 2 to the x is equal to 2 to the 5th raised to the 1/3. So 2 to the x is equal to 2 raised to the 5/3 power. What does this tell us? X is equal to 5/3. All right, last one like this. So for this one, I can't solve it, but I can change it into exponential. If I'm going to change it into exponential, remember, the ln of x, the natural log of x, is reading as log base e of x. Now, I don't have anything on the other side. Am I allowed to put x on the other side? No. Could I put a different variable? Yeah, let's put y. So what is this going to be? E to the y is equal to x. I cannot solve this. All I can do is change this to exponential. There's just too many variables. Okay, some special notes. So remember, we have log, base, argument, equals exponent. Right. The base can never be negative, and the argument can never be negative. So the base cannot be negative and the argument cannot be negative. The reason of that is if I have a base that's negative and I raise it to a fractional exponent, won't that mean, like, let's say it's like the square root, wouldn't that be imaginary? So we're only dealing with real numbers here for that reason. And if the base can never be negative, then your argument can never be negative, because that's the answer. It could be fractions, it just can't be negative. All right, are we ready for some more rules?
Yeah.
Okay, you'll probably remember this once I state it. We call this the laws of logs. You 100%ed this.
I remember those, don't worry.
All right, so if I have log base b, and there's multiplication in my argument of x times y, we can expand this, and this goes both ways. I can make this into the log base b of x plus the log base b of y. All right, next rule. let's say I have log base b, and in my argument I'm dividing x divided by y. We can change that. We can expand it into, any guesses? Multiplication we change to log addition. So division will change it into log subtraction. Look at that. We're going to have log base b of x minus log base b of y. Next one. If I have log base b of some argument raised to an exponent, we are allowed to pull that exponent in the front of the log and make it that exponent times our log base b of the argument. So those are our rules. All right, I'll let you write it all down, then we'll do our next sample problems. Do you think you need to memorize these?
What do you mean? Like you're asking us if we should memorize them or give them to us?
Yeah, do you think you guys should memorize
We
them?
could just put it on the test, no?
You guys should memorize them.
Word box.
Word box?
Oh, I
Okay,
remember that.
let's do some sample problems.
No.
I want different colors.
Rainbow.
Pick your own color again.
Rainbow? I didn't like
the
picking.
other rainbow?
This one?
I don't know.
That's like stars.
It's like galaxy.
Can we see all of them?
Let's see, yeah, go with
Should we
it.
try them all out and pick our favorite?
Let's go through every single color in the spectrum and
Swatch
figure
it.
out which one's the best one.
Swatch it. And that was kind of boring.
I don't know.
Okay.
I'm not feeling
All
it
of
though.
them.
Really? I sort of like it.
I like it. It's simple. Yeah. It has texture.
Yeah.
No problem in it, everyone.
Okay.
So wouldn't it be cool to go through the whole color spectrum and find out which one's perfect?
No. Okay, I want us to expand using laws of logs.
LOL.
So that means I don't want any products, so no products, quotients, or powers. Okay, first one. Log base 2 of 3xy cubed
That's like this.
I hate this one.
It's like the sky.
No, it's like mermaid.
Reminds me of like walking into the Justice store. Those little
No, it gives galaxy leggings.
kind of.
Yeah, and I hate those leggings.
Me too. I don't think anyone should like.
I'm not feeling this one.
What about the? I don't know.
Okay, so I want to expand this. In the parenthesis, I have 3xy cubed. Matt, come on. That's so wrong. Okay, what operation is between all of them? Multiplication. We could split log multiplication into what? Addition. So what is this going to be? It's going to be log base 2 of 3. I hate all these different colors. Me too.
Ooh, no, that was ugly.
Okay, I know. All right, I'm going back to black. Log base 2 of 3 plus, right? Isn't there multiplication between all of these? Log base 2 of x plus log base 2 of y cubed. But I'm not done.
Oh.
All right, because this is good. No, it doesn't equal anything. This is good. This is not good. Remember what I said.
Okay.
No products, quotients, or
Oh, we could switch.
powers. Now that 3, I'm not going to bring it in front of everything. That 3 only belongs to the y, right? So it's only going to go in front of the last log base 2. So we are now log base 2 of 3 plus log base 2 of x plus 3 times log base 2 of y. Now we have expanded it all.
Yeah.
That's it.
That's all it is.
I remember doing this.
Good. Next one. Log base 2 of x squared minus 5 over 2z raised to the 3rd power. Let's not use a z. Let's use a y.
So this goes from there.
You got it. Do you see how this exponent of 3 is on top of my whole entire argument, not just part of it?
Yeah.
So now this 3 is going to go in front of everything. So we're going to do 3 and then brackets. So it's getting pulled in front of everything. And then I'm going to go step by step here. I have log base 2 of x squared minus 5 over 2y. What do you think I'm going to do with that division in my argument? I got to change it to log subtraction. So now we have 3 times the quantity of log base 2 of x squared minus 5 minus log base 2 of 2y. No, we're okay. How many people think we're done?
Oh, I see a power.
How many people think we're not done?
Absolutely not done.
We're not done, but it's not because of the x squared.
Why not?
Because that x squared is not on the whole argument, it's on just part of the argument. So I can't do anything with that x squared.
Okay.
So it's not the x squared. That's done. I can't do anything with that. Any ideas? No, the 3 could stay out there. That's fine.
The Y?
Gianna? The 2y. Isn't there multiplication between the 2 and the y?
Yeah.
Yeah. So now we're going to have 3 brackets log base 2 of x squared minus 5 minus, I'm going to need a set of parentheses here because now I'm splitting that log and there's a minus. So this is going to be log base 2 of 2 minus log base 2 of y. I'm sorry, plus, not minus. Oh.
This one's all a picture.
So you have a choice. You can leave it like this, or if you wanted to distribute in that minus, you could. It's up to you. Do you guys want to leave it like this, or do you want to distribute in the minus?
We're good.
We're good?
Well, but I don't get why we didn't put the 2 in front if we put the 3 in front.
So we only put the exponent in front if that exponent is an exponent to an argument. So here, this exponent, that 3, was an exponent to that argument. And the other one, where we were here, when we split this all up, this 3 was an exponent to the argument of y. If it's just to the full argument, if it's just part of the argument, we can't do it. Yes,
I think
Nika?
it's worth it going to the Bears if they're gonna
Oh, we're not done.
reject me as well. Thanks.
Just hang with me. One more set of rules.
It's too stressful for me, so I'm not doing.
Gold.
Or rose gold.
Where is that?
It's right there.
This is
What?
gold.
Rose gold's the.
Oh, I like it. Sparkly.
You gave yourself one look. Oh, so it's not number 3.
This is log shortcuts.
Log shortcuts.
I'm so sad for you.
2.
Just leave the number 3 there. I wouldn't cross it out because it will make it worse.
Are we going to be doing a 3?
Now I'm going to start at 1 again.
Make your own problem and do it.
Oh, but there is a third log shortcut. Okay, log shortcuts. We'll call it A.
I'll make a little.
I feel like this all needs to be written in black. B raised to the log base B of t. Girls, you're having way too much fun in this class. Focus. All right, B raised to the log base B of t is just going to be t. And I'll show you what I mean. No, it's fine. If I have 2 raised to the log base 2 of 5.
Are you recording?
I am recording. Everyone's here, but sometimes people need to go back and...
Just fans instead of us.
I have some fans.
Yeah.
Okay.
Check it
Like a
out.
chunk of notes.
So if I have 2 raised to the log base 2 of 5, what I need us to see is I have some base raised to an exponent. If that log exponent has the same base as my original base, right? So what's the base of the log? 2. What's my original base of the whole problem? 2. If these are the same, it just ends up being the argument. It simplifies down right down to the argument. So this is just 5.
Oh, so that's all.
That's it. That's the shortcut.
You should put like 5 of those in the test, just bang them out.
I'll show you. Let's do a number that actually works. Let's do 8. Let me explain to you why. So I'll tell you why. What's log base 2 of 8? You guys don't have to write this down. It just seemed that some people were confused, so I want to explain to you the reasoning. If we have log base 2 of 8, isn't this 2 to the x equals 8?
Sure.
And 2 to what power gives us 8? 3. So this ends up becoming, this whole exponent ends up becoming 3. 2 to the 3rd power is 8. That always ends up working when it's like that. It always just ends up being the argument. Sometimes when I explain it confuses you more, but I have to. All right, next one. Is this the same idea? E to the ln of t is equal to t. Same idea. Daniela.
Yes. What?
I see your phone and you scrolling. It's bad for your concussion.
No, it actually helps my concussion because
No,
I
it
can't
doesn't.
focus on one thing at a time anymore.
No, let's try. Let's put the phone away. So we have E. I'm almost done, guys, I promise. ln of is log base E, right? Well, isn't this the same rule then? E to the log base E of t as the one we just did?
Yeah.
Yeah, so it's just t.
How is that different?
It's not different. It's exactly the same. It's the same rule, but I'm just writing ln instead of log.
Why is there so many letters?
Yeah, wait, I'm confused now we're getting from the first one to the second one. Like,
Remember, ln is log base E.
okay,
Okay.
that's cool.
Guys.
Wait, if mine is
No. You're not going to be confused when we do problems. I'm just writing out the rules right now.
Losing is
how many more rules are there?
Not much. Okay, log base B of B is equal to 1. What does this mean? This means if I have log base 2 of 2,
one.
it's 1. Exactly. Why? This is saying 2 to what power gives me 2? 2 to what power gives me 2? 2 to the first power gives me 2. That's why the log base B of B is 1. One more. One more rule.
That's it?
Then we'll try. Then we'll just practice, and then that's it. Log base B of B to the t is equal to t.
It's a made up thing.
So what does this mean? If I have log base 2 of 2 to the 3rd power will equal what number do you think? 3. Yep. And these are the 4 rules. How about I only do 2 more problems and then we'll stop, okay? Okay. I want us to evaluate.
This is use 3 pages of numbers. This is use. No, this is use.
Okay, using the shortcut. 2 raised to the log base 2 of 8. Just 8. Yay, Gianna. All right, next one.
Good job, Cookie.
I'm so proud of you. Okay, forget it. Forget it. Forget it. Forget it. No.
Why would you say that?
I'm sorry. I wanted to challenge you, but your brains are done. I'm not challenging you.
My brains have been done for a while. I just need to like practice it. I see you lazy.
Oh, I got it.
300.
300.
Wow.
Can I just do one more problem?
If that makes you happy, Miss Alvarez.
Just, no, it's not going to be so hard. It's just something that I didn't show you. I want us to write as a simple log.
There you go.
No, I should just stop it. Single log.
I'm not ready.
No, write it.
Trying to look for the page okay.
Not bad. Look.
Not bad at all.
Right.
So, I have a number in the front, right? Can I pull that number back as an exponent? That number in front I'm pulling back as an exponent. So this is, yeah, we're doing the opposite. We're working backwards now. So now this is going to be the ln of the quantity of x minus 2 raised to the third. Are we all okay with that step I just did?
Sure.
Sure? Okay, I'll take it.
Maybe.
And now I have 2 different logs that are subtracted with the same base because ln is log base e. So I can condense that. I can change subtraction to condense it back into what? Division. So when you pull it back into division, what you're going to do is you're going to pull out just one of the logs. In this scenario, our log is what? ln. Our log is ln. So I'm pulling out just one ln, and then I'm going to have x minus 4 divided by the quantity of x minus 2 cubed. That's it. And then we stop there. And we're done.
I like that though.
Okay?